discussed about the basics of degrees of freedom. I hope you understood the meaning for degrees of freedom and how to find out the degrees of freedom or mobility for different mechanisms. Okay, I think a few examples were discussed in the previous class. Now I discuss a few more examples related to mobility of simple mechanisms. So if you look at this particular mechanism, how many links you are observing? Tell me how many links you are observing here. Simply look at the diagram and tell me.
8, 8, sir.
8 அதிலே மென்ஷன் பண்ணியிருக்காங்க. லெட் மீ பிரீஃப் வாட் ஆர் ஆல் தி லிங்க்ஸ். ஸோ எங்கே ஃப்ரேம் கிரவுண்ட் அப்படி இருந்தாலும் இட் இஸ் கோயிங் டு பி த ஒன் ஃப்ரேம். ஸோ கிரவுண்டுன்னு மென்ஷன் பண்ணியிருப்பாங்க, சம்டைம்ஸ் ஆர் ஃப்ரேம் மென்ஷன் பண்ணியிருப்பாங்க. ஸோ வாட் எவர் மே பி த கேஸ், இட் இஸ் கோயிங் டு பி ஒன் லிங்க். Okay, here one ground is there, so let it be link 1. So here one ground, so here one ground, here one ground. So link number 6 is attached to the ground. Similarly, slider 8 is attached to the ground, and link 2 is attached to the ground, and 4 is attached to the ground. So likewise, we are having a frame 1. Okay, and this is link 2. This is your link 2, and this is your binary link 3. So link 2 is also a binary link. Link 3 is also a binary link. Link 4 is also a binary link. Then link 5, what type of link it is? What type of link it is? 5?
Ternary, sir.
Ternary.
Yes, it is a ternary link because we are having 3 motion transfer points. So this is 1, this is 2, and this is 3. So it is a ternary link. So 6, of course, it is a binary link. 7, it is a binary link. 8, it is a slider. Okay, it is a slider. It is sliding over the ground. So totally we are having n different links. So number of links equivalent n is equivalent to 8. Okay. Now, so normally the diagram will be given like this. So we need to draw the kinematic diagram. We know how to represent a binary link, a ternary link in kinematic point of view. So if you look at a frame, it is mentioned like this. Okay, it's a triangle-like shape, and the fixity, for fixity, it is represented like this. For every frame, it will be represented like this. These are all frame 1. And 2, it is a binary link. It is a simple line diagram connecting 2 nodal points. And similarly, 3, 4, 6, 7, all are binary links. And 5 is a ternary link. Normally, it will be represented like this. And 8 is a slider. It is sliding over the frame. So, I hope you understood the difference between the actual mechanism and the representation of the kinematic diagram. Okay, so for exam point of view, normally we use the kinematic representation. So there is no much difference between these two. It is a simple kinematic representation. Now we know that there are 8 links. Okay, we know that there are 8 links in which we need to use what rule to find out the mobility. What is the rule we are supposed to use? Mobility or degrees of freedom conducting. Okay, yesterday we discussed one
Groupler's equation.
Yes, Groupler's equation or Kurzbach equation. So what is that? M is equal to 3 into
3 into n minus 1
2
minus 2 n minus 1 h.
1 h. In which n is number of links, L is the number of lower pass, and h is higher pass. So now tell me, we know number of links is 8. Okay, how many lower pass we are having? Look at the kinematic diagram and tell me how many lower pass we are having. I hope all are lower pass. We don't have any higher pass here. Okay, so all are lower pass. How many lower pass are there? How many lower pass are there?
4, sir.
எவ்வளோப்பா? Please repeat.
8, sir.
8. Let me check it. So here it is one lower pair. Do you agree? So the connection between the frame and link 2,
Yes, sir.
it is one lower pair. It is lower pair 2. Then this is lower pair 3. Then this is lower pair 4. then this is lower pair 5, and slider kum frame ku irukkiradhu one lower pair. Okay, sliding contact
Six.
there is lower pair 6, then lower pair 7,
Seven.
lower pair 8, then lower pair 9. That's all. Anything missing? 9. 9 is okay. Okay, here if you look at the connection between the link 3 and 5, which is link 3, this one, which is link 5, this one. Okay, so link 3 and link 5 are connected by means of one pin joint. Okay, at the same time link 4 and link 5 are also connected at the same nodal point. So tell me how many nodal points here, how many connections, how many pin joints inga irukumpa?
2, sir.
2, sir.
Now tell me how many lower pairs are there?
11.
Right? 11 or 10?
10,
10,
sir.
sir. 10, sir.
10. Okay, so மற்ற இடத்துல கால்குலேட் பண்ணது எல்லாமே கரெக்ட். இந்த பர்டிகுலர் பாயிண்ட்ல மட்டும் there is connection between the link 3 and 5 and 4 and 5. So two different pin joints are used, so it forms two lower pair. So there are totally 10 lower pairs available here. So try to write here. So 3 into number of links 8, 8 minus 1 minus 2 into number of lower pairs 10 minus it tends to 0. Okay, now 3 into 7 evalapa 21 minus 20. So how many D's of freedom this mechanism is having?
1, sir.
1, sir.
1. So it is very simple, it's very easy to find out. Is it okay?
Yes, sir. Yes.
Yes. Okay, the same has been represented here. Mobility is equivalent to 1. Now look at this mechanism. Look at this mechanism and tell me how many links are there, how many lower pairs are there. Links, of course, you can observe from the diagram itself. How many links we are having?
6, sir.
6. Number of links equivalent to 6. Okay, so ground which is 1, it is a Turner link which is 2. It is also what type of link it is? 3.
Binary.
Binary link. Okay, then what type of link it is? 4. Binary. Then 5 is also a binary, and 6 is also binary. 6 is attached to the ground, and 2 is also attached to the ground, and 3 is also attached to the ground. So there are totally 6 links. Okay, out of which one Turner link and 1, 2, 3, 4 binary links we are having, and one frame. Okay, now tell me how many lower pairs we are having. How many lower pairs we are having?
Sir, is it 7, sir?
Oh, so this
Sir,
is
the frame, sir.
frame and link 2.
Sir, 8.
1. This is 2. Then this is 3. Then this is 4. Then here 2 joints. 4 and
Yes, sir.
6 are connected, and 4 and 5 are connected. So here
Connected,
2.
2,
Here
sir.
2. 6 ஆயிடுச்சு. Here 7. Correct.
7, sir. Yes, sir.
What about this one?
Round.
So number of lower pair is equivalent to 7. Okay, now what is the pair between link 3 and 1? It is mentioned that it is half joint. So half joint means it is like a cam and follower. So you will be having line contact between these two.
Higher pair, sir.
It is a higher pair. So higher pair is equal to how much? 1.
1, sir.
In earlier case, you did not observe any higher pair, where here you can observe one higher pair between the links 3 and 1. So because the contact between the link 3 and 1 is going to be a line contact. Okay, so definitely it is going to be a higher pair. So H is equivalent to 1. So now you can see the answer. N is equivalent to 6, lower pair is 7, and higher pair is 1.
1, sir.
If you apply in this formula, mobility will be what? 0. Okay, we'll be getting 0 mobility. So this particular mechanism is going to be act like a structure. It is not going to be act as a motion transfer mechanism. Okay, simple. Is it simple?
Yes, yes.
Okay. So first one is mobility is equivalent to 1. So it becomes a completely constrained. So mobility 1 and it is a completely constrained mechanism. Whereas mobility is 0 means it becomes a structure. Now tell me this mechanism. I'm not going to give any hint. You tell me the mobility. I want only answer. Mobility is equal to how much? You identify how many lower pairs are there, how many higher pairs are there, how many links are there, in which how many binary links and how many ternary links, everything you find out. Vikram Raju, please mute your mic. What is the solution for m is equal to 1? It will take hardly 30 seconds to find out. So which link is fixed? Pa? Which link is fixed?
Sir, number 1, sir.
Number 1, correct. It is a ternary link, it is fixed. Okay. Getting late to get the solution. So tell me, here number of links is equal to 6 and lower pair is 7 and higher pair is 0. The substitute you will be getting the mobility. Sometimes notation will be m, sometimes notation will be f. So here mobility is equal to how much? 1. Are you able to identify how many lower pairs are there? 7 lower pairs. Everything தெரிஞ்சதப்பா?
Yes, sir.
Okay. So here one.
Sir, explain பண்ணுங்க sir.
Okay. So here the connection between the link 1 and 2. So here one lower pair. Then connection between the link 1 and 6. So another lower pair. So connection between the 5 and 6. The third lower pair. The connection between the link and 3 and 5. So this is the fourth lower pair. Connection between the second and third link. So fifth lower pair. The connection between the third and fourth link. So this is sixth lower pair, and connection between the 4 and first link. So it is seventh lower pair. Okay, because the 3 and link 1 and 3 are ternary links. It is not binary link. Okay, link 1 and 3, it is mentioned that it is a shaded portion. So it means that it is a single unit. Single unit means it is a ternary link. Because we are having 3 motion transfer points, it is a ternary link. Okay, don't assume this each and every line in the third link as a binary link. Okay, so it is a hatched portion becomes a ternary link. Is it clear? Please respond. Is it clear or not?
Yes sir.
Yes, sir. Yes,
Yes sir. Yes sir.
Okay. Tell me this link, this mechanism. So here the pairs are clearly mentioned. So links are clearly mentioned and pairs are clearly mentioned. So it is very easy to find out. Any response? So here the mobility is
Sir, lower class, சமணங்களா sir?
which one? Yes,
The
correct. Lower pair is 7. Number of links 6.
Okay, sir.
Okay, at the intersection of this particular point. So here binary link 2 and 3 are connected by means of a pin joint, and binary link 3 and 4 are connected by means of another pin joint. So here you are having two lower pairs. Okay, so here one lower pair, here one lower pair, so here one lower pair, so here one lower pair, and here one lower pair. So totally 1, 2, 3, 4, 5 plus 2, 7 lower pairs, and there is no higher pair. So if we substitute, we will be getting mobility is equivalent to 1. Clear?
Yes, sir.
Yes, sir.
If you are having doubts, please stop me. Don't hesitate to ask the doubts. So this is for homework. Please go through the video so that you can solve it later. These are all homework problems. Let me post it in your group today. Solve a simple application-oriented problem. Now, if you look at the problem, calculate the mobility of the shearing machine used to cut and trim electronic circuit board laminates. So look at the mechanism and tell me how many links you are having here. If you are able to identify the number of links in this problem, then it is very comfortable to solve any problem.
4 links, sir.
4 links, exactly correct. What are they, ma?
Sir, that bolted fixed frame, sir.
Yes. So
One,
this like vice mark, it is assumed to be a
that handle 2, sir.
yes. This is link 1. It is assumed to be a frame which is bolted on the table. Okay. So it is acting like a frame. Then this handle is going to be link 2. Okay. So this entire portion link 2. Then this particular fellow is called link 3, and this particular slider, okay, this particular slider is going to be link 4. So when you apply force along this handle like this, so this particular portion is going to lift like this. So your link 3 is going to move downwards, so that your slider is also going to move downwards, so that this sheet, okay, sheet clear. The sheet on this sheet is nothing but electronic circuit board sheets. It is going to be sheared, or it can be cut uh, into pieces. Okay, so this is a particular mechanism used for cutting electronic circuit board laminate trim. Okay, there are 4 links. So frame 1, this handle is 2, this is link 3, and the slider like arrangement. Slider is moving along the frame. Okay, it is link 4. So let me show the kinematic diagram for the same mechanism, so you can relate. Okay, so frame is like link 1, okay, link 1, and frame and link 2 are connected. So here if you look at kinematic diagram, this frame and link 2 is connected, then link 2 and link 3 are connected. So link 2, this is your link 3. Here is this is your link 3, and link 3 and link 4 are connected. So this is your link 3, so this is your slider link 4, and slider 4 is sliding along the frame. So this is how you need to draw the kinematic diagram for better understanding. Okay, so there are 4 links. The number of links is equivalent to 4. How many lower pairs are there? How many higher pairs are there?
5, sir. Lower pass.
5 lower pairs. What are they? What are the 5 lower pairs? Let me come to the original application diagram. So 2 and 1 are connected by means of this particular point. In the point connect pannirukkom. So 1 lower pair, and link 2 and 3 are connected by means of this pair, this point. 3 and 4, this one. Then 4 is sliding over the 1. Okay, so that is also a forms one sliding pair. So 4 ஆயிடுச்சு. இன்னொன்னு இருப்பா, how many lower pairs are there here?
4 only, sir.
4 only. Yes. So link 1 is nothing but the base, link 2 is your handle, and link 3 is your cutting blade. So here it is alternatively mentioned, and link 4 is bar that connects the cutter with handle. So it is 3 and 4 are alternately mentioned here. So number of links are 4, number of lower pairs are 4, there is no higher pair. So you will be getting the mobility how much? Mobility is equivalent to
1, sir.
1. So by looking at the diagram, you should be able to draw the kinematic diagram, and you should be able to identify how many links are there, how many joints are there, how many low pairs, how many higher pairs are there, and so that you will be able to find out the mobility. Okay. Any clarifications required? Any doubts?
No, sir.
No, sir.
Okay, so these are all homework problems. Let me give as a homework. Now we move on to the inversions of 4-bar mechanism. So hope you know what is meant by 4-bar mechanism, correct? So how many links are there in 4-bar mechanism?
4, sir.
4. So the
4, sir.
first one is the frame. So link 1 is your frame. So this is frame, and this is your crank. Why it is so called crank? Why it is so called? What is meant by crank?
Sir, it can
It can rotate, sir.
60 degrees.
Yes, it can completely rotate through 360 degree. That's why it is called as crank. So what is your coupler here? Link 3, correct or not?
Link 3. Yes.
Yes, coupler is your link 3, which connects your crank, which is input link, and your output link is your rocker. So it is going to make some oscillations. So it is called rocker or output link. Okay, so whenever a crank is input is given to the crank, so I'm going to give input to this crank through some prime mover or motor. So this crank is going to rotate 360 degree, so that the motion of the crank is going to be transferred to the rocker, okay, through the coupler. Okay, so I hope you are able to appreciate the working of 4-bar mechanisms. Yesterday I have shown a demonstration on working of the 4-bar mechanism. So let me show once again in another video. So are you able to view the video, pa?
Yes, sir.
Sir.
This pink, baby pink color is your crank, and this is your coupler, and this is your rocker, and
Rocker.
the entire blue color is your frame. So frame வந்து link 2 crank கூட connect பண்ணிருக்கோம், output link கூடயும் connect பண்ணிருக்கோம், rocker கூடயும் connect பண்ணிருக்கோம். So now you can view the motion of. Are you able to view hear the audio, pa?
Yes,
Yes, sir.
Yes, sir. கேக்குதுங்க sir.
Okay. Now you can see the crank is completely rotating 360 degree, and rocker, what type of movement it is? Rocker, pa? What type of movement rocker is making?
oscillation.
Oscillation. So
Oscillating, sir.
please completely view the motion of rocker. It is going to move certain angle, only 60 degree or 90 degree, and the angle மட்டும் தான் இது பண்ணும், make பண்ணும். So that is why it is called rocker. So simply at the end of the rocker, if you attach some wiping blade, then it can be used for wiping of your windshield wiper system used in cars. Normally input will be given at the crank. So crank ஓட endல வந்து prime mover connect பண்ணிருப்பாங்க, so that the prime mover motion is transferred to the crank. Normally the prime mover will be rotating continuous 360 degree. Similarly, the same manner crank will be rotating. Please, someone mute, pa. Please then. Dharanidharan, please mute. Now we move on to the inversions of the kinematic chain, that is 4-bar mechanism. So what is meant by inversion? Inversion in the sense a mechanism is one in which the one of the links is fixed and we are going to observe what is the motions that other links are going to make. So we know that we are having 4 links in a 4-bar mechanism. So we are going to change the fixity conditions of the different links in a 4-bar mechanism, and we'll be looking at what is going to happen, what other links are going to make, whether it is going to make complete revolution or whether it is going to make partial revolution like rocking, okay, or it is making sliding motion. So those are all will be dealt in the inversions of kinematic chain. So a mechanism is one in which one of the links of a kinematic chain is fixed. Then observing the motion of other links is called inversion. So inversion is created by grounding different links in a kinematic chain. So we know that we are having 4 different links like frame, crank, coupler, and rocker. So we are having 4 links in a 4-bar mechanism. So for each and everything we are going to fix different links and we are going to observe the other motions. So how many number of possible inversions in a 4-bar mechanism? How many inversions are possible, in a 4-bar mechanism? How many inversions are possible?
1, sir.
How? As I told,
So
we are
3.
going 3. We are having 4 links, so 4 times we can fix. So 4 inversions are possible now. First, let me fix the frame, and I'm going to give input to the crank. I'm going to observe what the rocker is going to make. And second thing, I'm going to fix the crank. Okay, I'm going to change the fixity condition to the crank. I'm going to give the input to the coupler or frame. Then I'm going to observe what is going to happen to the other links. Similarly, coupler going to fixed motion will be given to the other links, and I'm going to observe what other links are going to make. Similarly, rocker. So 4 inversions are possible. Correct or not? 4 time fix பண்ணலாம் இல்லையா? Fixity change பண்ணி I'm going to observe. Now, so normally 4 links are used in 4-bar mechanism. So out of which we'll be having one will be the shortest link and another one will be the longest link, and remaining 2. Okay, for example, if you are using 3 centimeter link, okay, for example, P is 3 centimeter and uh, L is 11 centimeter and this is 5 centimeter, Q is 5 centimeter and S is 3, P is 7. Okay, so normally 4 links will be used. The shortest dimensions of the link is mentioned as S, so which is going to be S, and the longest link, okay, that is going to be mentioned as L, so which is 11 centimeter link, and other 2 links are P and Q. Okay, so for 4 link இருக்கும் 4க்கு different dimensions இருக்கும். So one will be the shortest dimension, other will be the longest dimension, and the intermediate 2 வந்து P and Q னு we are going to denote it as. So we are going to use some laws to predict the rotatability conditions of the links, okay, used in a 4-bar mechanism, okay, which indicates that S plus L should be less than P plus Q. So in the மாதிரி condition which is satisfy பண்ணா மட்டும்தான் then I am able to attain a complete rotation of cranks, okay, or at least one of the links, okay, which means that some of the shortest and longest link lengths should be less than some of the lengths of other 2 links. In the condition satisfy பண்ணிருக்கோம். Just try to understand, this is sum of shortest and longest links should be less than or equal to other two links. Okay, sum of lengths of other two links. So if this condition is satisfied, definitely you will be getting at least one of the links should be rotating complete revolution, so that it will be comfortably connected with your prime mover. Okay, because your prime mover is rotating continuous 360 degree. So if this condition is satisfied, at least one link will be capable of making full revolution with respect to the ground point. So in this we are having two classifications: class 1 kinematic chain, okay, class 1 kinematic chain and class 2 kinematic chain. So class 1 kinematic chain is nothing but which obeys the Greshoff's law. So this is your Greshoff law. So this is your Greshoff's law. So in the law obey panachana, which is nothing but class 1 kinematic chain. If this law is not obeyed, then it becomes to class 2 kinematic chains. So in that case, none of the links are going to make complete revolutions. So first let us look at the first inversion. So what is mean by first inversion? Which is nothing but grounding of link adjacent to the shortest link. So as I mentioned, in a 4-bar mechanism, you will be having a shortest link, a longest link, and the intermediate links are P and Q. So 4 link irukku. First inversion is nothing but grounding of link adjacent to the shortest link. So which is shortest link for here? It is a 4-bar mechanism.
Yes, sir.
Yes, S is your shortest link, L is your longest link, and P and Q are other two links, which is intermediate dimension of S and L. So first inversion in the sense we are going to fix the grounding of link adjacent to the shortest link. So which is shortest link? It is S. Okay. Which one is adjacent to the shortest link?
Q.
Q and L ரெண்டுமே இருக்கு இல்லையா? So first inversionல let me fix the Q and another inversion I'm going to fix the L. So let me fix the first inversion. In the first inversion I'm going to fix Q, which is adjacent to the shortest link. S க்கு adjacent link வந்து Q. I'm going to fix Q as my first inversion. If I fix Q, okay, and if I give the input to the crank, so prime mover வந்து shortest link க்கு connect பண்ணிட்டேன்னா, so this S, the end point of S is going to make a complete revolution. It is going to make a complete revolution along this path. So this is the path traced by the shortest link. So if this is the case, your P is going to be your output link. It is going to make some rocking action. So in the Mari, this is the path traced by your P. So L is going to act like a coupler. So as I shown the demonstration, so those mechanism belongs to the first inversion. So grounding of the link which is adjacent to the shortest link. So this is second inversion. Okay, second inversion is nothing but again fixing of link grounding of link adjacent to the shortest link again. So earlier case we fixed Q. So now L is also a link which is adjacent to the shortest link. So shortest link is that. So இதுக்கு adjacent வந்து L. So this is fixed now. Now this is fixed. So fix பண்ணியாச்சு. Once again I am giving input to the shortest link which is called as crank here. I am attaching a prime mover here. If I attach the prime mover, it is going to rotate a complete 360 degree rotation, 360 degree. So along the path traced by this hidden line, so that your point P, okay, this point is going to be moving like this. So this is the path traced by P and Q. What is Q? What is Q now? It is going to act like a coupler. In the previous inversion, L is coupler because Q is fixed. In this case, Q is going to be a coupler and L is fixed. So So this particular point is making a rocking motion. Okay, so this is the path traced by the point, point that is this particular point of P. So both these two inversions are called as crank rocker mechanism. Crank rocker mechanism. Why it is so called crank rocker mechanism? What is mean by crank? What is mean by crank?
360 degree.
A
Sir,
link
which can rotate 360 degrees.
yes, a link which is rotating completely 360 degree. So in this case, okay, in this case the link S is going to rotate a complete 360 degree, okay, for both cases. So it is called crank, and the output link is going to make some oscillatory motions. Okay, so this is the path traced by the output link. So it is going to make some rocking motion. So in the mari case la, if you fix the link which is adjacent to the shortest link, you will be getting a crank rocker mechanism. Okay, எங்கப்பா பார்க்கல crank rocker mechanism? Where you can see the crank rocker mechanism?
Wiper.
Wiper, sir.
Yes, windshield wiper system, in which the shortest link will be rotating 360 degree, and the output link, which is nothing but the wiper blade, is going to make rocking motion, so that the car dust particles and moisture will be wiped off from the car glass. Okay, so this is application of the first inversion. So rendu similar irukanaala we are keeping it as first inversion, because we are fixing the shortest the link which are adjacent to the shortest link. So both are similar, so we are keeping it as first inversion. So the mechanism what we are obtaining is crank rocker mechanism. So now you can able to view the animation of the crank rocker mechanism. So crank is rotating complete 360 degree, and rocker is making rocking motion. So here coupler is like a Turner link. Okay, don't bother about the coupler. Please try to understand the motion of the input link and output link. Is it clear? So example is car windshield wiper system.
Okay, sir.
Okay, here you can see this green color. So green color is your crank. Okay, and this is your frame, and this blue color is your coupler, and this is your rocker. So don't bother about this yellow color, and these are parallelly connected. Okay, so you just look at this particular portion. So green color is crank, and this is the frame, and this blue color is coupler, and this another blue color is rocker. So try to understand the motion of the rocker and crank. Crank is rotating 360 degree revolution, and the rocker is making a partial rotation. So rocker kuda blade connect பண்ணிருக்கோம், windshield wiper blade connect பண்ணிருக்கோம், so that cleaning action is being happen. Clear? Is it clear? Shall we proceed?
Yes, sir.
Okay. As I told, the first two are similar, so we are having same inversion. So second inversion is grounding of the shortest link. Okay, first case enna pannom, we are fixing the links which are adjacent to the shortest link. Shortest link edhuvo adukku adjacent links fix pannom. Now we are fixing the shortest link itself. So which is shortest link here? So this one, this is the shortest link, it is fixed now. Okay, if it is fixed, so we are having another link. So in a motion கிடைக்கும் பார்த்தீங்கன்னா, we will be having double crank mechanism or drag link mechanism. So that is your link L and link Q both are going to rotate complete 360 degree rotation whenever you are fixing the shortest link. Okay, shortest link fix பண்ணீங்கன்னா, other two links are going to rotate complete revolutions. So which is called as double crank mechanism, or sometimes it is called as drag link mechanism. Okay, so this is animation for drag link mechanism. So this is your fixed link. Okay, this is your fixed link. It's mentioned like this. If this is fixed, so observe the motion of other links. Okay, so this link all are going to make a complete 360-degree rotation along the path traced by this one. So this is the path traced by one link, path traced by one link, and this larger circle is going to be the path traced by the other link. So ஒரு particular mechanism 4-bar mechanism, if you are fixing very shortest length, definitely you will be able to get double crank mechanism. So another example, if the shortest link is fixed, okay, shortest link is fixed and other two links are of same dimension, okay. So for example, in the link same dimension irundhuchina, here also you will be getting double crank mechanism. So inga pathinga locomotives la you can see the double crank mechanism. It is also called as a drag link mechanism. Then the third inversion is grounding of link opposite to that of shortest link. Okay, which is shortest link here, ma? Which is shortest? Yes, is the shortest link. The first inversions we fixed L and Q, and the second inversion we fixed the shortest link itself, and here the third inversion. So the third inversion is grounding of link opposite to that of shortest link. So shortest link is S, opposite to the shortest link is P. So if you fix the P, now let us look at what mechanism that we are going to get. So we'll be getting rocker mechanisms. Okay, rocker mechanism, or we can call it as double rocker mechanism. So what is the meaning for this? What is the meaning for this?
Two oscillating motion.
Yes, none of the links are going to make what? Complete 360 rotation. Only whatever may be the link, or whatever may be the input we are giving, the output link and input link, all are going to make what? Partial rotation only. But coupler makes full rotation, but the prime mover cannot be connected with the coupler because it is making it is a moving part. So coupler cannot be connected with the prime mover. Either the coupler prime mover can be connected with Q or L. Okay, because of moving link is your prime coupler. So here S is going to be acting like a coupler. So S cannot be connected with the prime mover. So in the input கொடுக்கவே முடியாது. So you can connect your prime mover either here or here. In that case, L is also going to make partial rotation. Q is also going to make partial rotation. So you will be getting double rocker mechanism. So you can see the animation now. So the link which is opposite to the shortest link. Shortest link is that green color. Adukku opposite is this black color. So if it is fixed, okay. So the red color and the blue color links are going to make rocking motions. So the red color is the path traced by the red color link, and this blue color hidden line is the path traced by the blue color link. So both are rocking motions. So even though the coupler is making the rotations, so either some path trace பண்ணுது, but prime mover cannot be connected with the coupler because it is continuously in motion. So this type of arrangement you can see in your steering principle. So Ackermann steering principles, you can see the motion of this particular mechanism. Both wheels are going to make the partial rotation. So we have seen different inversions of 4-bar mechanism and the corresponding applications. Any doubts up to this? Any clarifications? Please respond. Any doubts? Don't
No, sir.
any clarity required? Others, please respond.
No, sir.
Okay, I think it is clear. Now
Hello,
we
sir.
move. சொல்லுங்கப்பா.
சார் இப்போ இன்வெர்ஷனுக்கான டெஃபினேஷன் மட்டும் ஒரு தாட்டி சொல்லுங்க சார்.
Inversion என்னன்னா, we are having 4 links in a 4-bar mechanism. Okay, we are having 4 links. So this is your frame. Frame is 1, and this is your crank. This is link 2, and this is your link 3. It is coupler, and link 4 is your rocker. கரெக்டா? ஒரு 4 bar மெக்கானிசம்ல 4 லிங்க் இருக்கும். These are all the 4 links. இதுல வந்து கண்டிப்பா ஒரு ஷார்ட்டஸ்ட் லிங்க் இருக்கும். ஷார்ட்டஸ்ட் லிங்க்னா எந்த 4 லிங்க்ல எது லீஸ்ட் டைமென்ஷனோ அதான் ஷார்ட்டஸ்ட் லிங்க்னு சொல்லுவோம். இன்னொரு லிங்க் வந்து கண்டிப்பா லாங்கஸ்ட் டைமென்ஷன்ஸா இருக்கும். ஓகே, மீதி 2 அதர் 2 வந்து இன்டர்மீடியேட் பிட்வீன் எஸ் அண்ட் எல். ஃபார் எக்ஸாம்பிள், எஸ் வந்து 3 சென்டிமீட்டர் அப்படின்னா, எல் வந்து 11 சென்டிமீட்டர் அப்படின்னா, யுவர் பி அண்ட் கியூ வில் பி between this. So P may be 5 centimeter and Q may be 7 centimeter. So இருக்கலே shortest link வந்து S னு வெச்சுக்கணும், longest link வந்து L னு வெச்சுக்கணும், other links வந்து P and Q னு வெச்சுக்கணும். ஓகே, இப்போ இன்வர்ஷன் அப்படின்னா என்னன்னா, இருக்கலே ஷார்ட்டஸ்ட் லிங்க் ஃபர்ஸ்ட் இன்வர்ஷன் அப்படின்னா என்னன்னா, இருக்கலே ஷார்ட்டஸ்ட் லிங்க் எதுவோ அதுக்கு அட்ஜசன்ட் லிங்கை வந்து ஃபிக்ஸ் பண்றது. ஸோ அஷ்யூம் த கிராங்க் தான் வந்து ஷார்ட்டஸ்ட் லிங்க்னு வச்சுக்கோங்க இந்த கேஸில். ஸோ கிராங்க் இந்த லிங்க் 2 வந்து ஷார்ட்டஸ்ட் லிங்க். ஸோ திஸ் இஸ் 3 சென்டிமீட்டர். ஓகே, ஸோ திஸ் இஸ் 11 சென்டிமீட்டர், திஸ் இஸ் 5 சென்டிமீட்டர், அண்ட் திஸ் இஸ் ஃப்ரேம் இஸ் 7 சென்டிமீட்டர் அப்படின்னு அஷ்யூம் பண்ணிட்டீங்கன்னா, ஃபர்ஸ்ட் வந்து வி ஆர் ஃபிக்ஸிங் த லிங்க் விச் இஸ் அட்ஜசன்ட் டு த ஷார்ட்டஸ்ட் லிங்க். இருக்கல ஷார்ட்டஸ்ட் லிங்க் எதுப்பாங்க?
3 சார், அட்ஜசன்ட் வந்து
7 இருக்குது, 11 இருக்குது. கரெக்டா? 3க்கு அட்ஜசன்ட் வந்து பக்கத்தில் இருக்கிறது. 3க்கு அட்ஜசன்ட் 7 இருக்கு, 11 இருக்கு. ஃபர்ஸ்ட் we are fixing 7 centimeter link, and we are going to observe what motions if you give the input to the crank, that is 3 centimeter link, what motion the 5 centimeter link is going to give அப்படின்னு பார்க்க போறோம். அதுதான் ஃபர்ஸ்ட் இன்வர்ஷன். சிமிலர்லி செகண்ட் இன்வர்ஷன் என்னன்னா, இப்போ ஃபர்ஸ்ட் 7 சென்டிமீட்டர் லிங்க் ஃபிக்ஸ் பண்ணோம். நவ் we are going to fix 11 centimeter link. அதை ஃபிக்ஸ் பண்ணிட்டு again I am going to give motion to the 3 centimeter link, and I am going to observe what the 5 centimeter link is going to make. ஸோ இந்த ரெண்டு கேஸ்லையுமே பார்த்தீங்கன்னா, எப்போ வந்து ஷார்ட்டஸ்ட் லிங்க்குக்கு பக்கத்தில் இருக்கிற லிங்க்ஸ் எல்லாம் ஃபிக்ஸ் பண்ணீங்கன்னா, definitely you will be get crank rocker mechanism. இந்த ஃபர்ஸ்ட் இன்வர்ஷன் you will be getting crank rocker mechanism தான் கிடைக்கும். கண்டிப்பாக இந்த கிராங்க் வந்து ஃபுல் 360 டிகிரி ரொட்டேட் பண்ணும். அவுட்புட் லிங்க் வந்து ஒன்லி இட் வில் மேக் பார்ஷியல் ரொட்டேஷன். ஓகே, ஸோ ரெண்டும் சிமிலராக இருக்கிறதுனால ரெண்டும் ஃபர்ஸ்ட் இன்வர்ஷன் வச்சுக்கிறோம். ஈவன் தோ ரெண்டு ஃபிக்ஸிலிட்டி வச்சிருந்தாலும் ரெண்டும் சிமிலர், அதாவது ஷார்ட்டஸ்ட் லிங்க்கு பக்கத்தில் இருக்கிற லிங்க் ஃபிக்ஸ் பண்ணியிருக்கோம். ஸோ இதை வந்து ரெண்டும் சேர்த்து ஃபர்ஸ்ட் இன்வர்ஷன் வச்சுக்கிறோம். நெக்ஸ்ட் கேஸ் வந்து ஷார்ட்டஸ்ட் லிங்கே ஃபிக்ஸ் பண்ணுறது. இங்கே ஷார்ட்டஸ்ட் லிங்க் எதுப்பா?
3 சார்,
3 சென்டிமீட்டர். ஸோ செகண்ட் இன்வர்ஷனில் ஷார்ட்டஸ்ட் லிங்க்கை ஃபிக்ஸ் பண்ணிங்கன்னா வாட் மோஷன் வில் பி கெட்டிங் அப்படின்னு பார்க்கணும். ஸோ ஷார்ட்டஸ்ட் லிங்க்கை ஃபிக்ஸ் பண்ணிவிட்டு இன்புட் வந்து இந்த 11 சென்டிமீட்டருக்கோ இல்லை 7 சென்டிமீட்டருக்கோ கொடுத்தீங்கன்னா, டெஃபினெட்லி போத் லிங்க்ஸ் இஸ் கோயிங் டு மேக் டபுள் கிராங்க் மெக்கானிசம். அப்படின்னா ரெண்டுமே சுத்துன்னு இருக்கும். as I shown in the animation itself. So double crank or drag link mechanism சொல்லுவோம். So whenever the shortest link is fixed, other adjacent two links are going to make complete revolution. So third inversion எப்படின்னா, the link which is opposite to the shortest link. இங்கே லிங்க் 3 தான் ஷார்ட்டஸ்ட் லிங்க், அதுக்கு ஆப்போசிட் இருக்கிறது 5 சென்டிமீட்டர் லிங்க். இதை ஃபிக்ஸ் பண்ணிட்டீங்கன்னா யூ வில் பி கெட்டிங் டபுள் ராக்கர் மெக்கானிசம். டபுள் ராக்கர் மெக்கானிசம் அப்படின்னா இன்புட் 11 கொடுத்தாலும் சரி 7 கொடுத்தாலும் சரி, both links 7 and 11 centimeter links are going to make only rocking motions. Okay, you will be getting like this only. Okay. So provided you should obey the Greshoff's law. அதாவது sum of இது எப்போ இது ஒர்க் அவுட் ஆகும்னா, Greshoff's law சாட்டிஸ்ஃபை பண்ணும்போது தான். Greshoff's law is nothing but S plus L is always less than P plus Q. இந்த கண்டிஷன் சாட்டிஸ்ஃபை பண்ணா மட்டும்தான் இந்த ஃபிக்ஸிடிட்டிக்கு இந்த மெக்கானிசம்ஸ் கிடைக்கும். ஓகே, கிளியர்? Any other doubts? Any clarity required?
No, sir.
Okay. Now we look at a glance what the Greshoff's law is violated. So அந்த மாதிரி கேட்டகரி வந்து என்ன சொல்றோம்னா, கிளாஸ் 2 kinematic chain சொல்றோம். That means in the previous case S plus L will be less than or equal to P plus Q. Okay. In this case it is violated class 2 kinematic chain. So S plus L will be greater than P plus Q. For mechanism, shortest to longest to add பண்ணீங்கன்னா அது ரெண்டோட summation வந்து other two links ஓட summation ஓட greater இருந்துச்சுன்னா it is violating Greshoff's rule or law, then it belongs to the category of class 2 kinematic chain. So இந்த மாதிரி கேஸ்ல எந்த லிங்க்குக்கு இன்புட் கொடுத்தாலும் சரி all the links are going to make only rocking motion. So none of the links are going to make complete revolutions. So here look at this. If this law is violated, S plus L is greater than P plus Q. So இது மாதிரி வந்துச்சுன்னா ஸோ எங்க இன்புட் கொடுத்தாலும் சரி ஸோ திஸ் எந்த லிங்க் ஃபிக்ஸ் பண்ணாலும் சரி other links are going to make only rocking motions. So here look at all the possible combinations. So here இப்போ fixity இங்கே மாற்றிருக்கோம். So these links are making rocking motions. Next here it is fixed here. Then if I give input and output, automatically other links are going to make rocking motions. And here it is fixed here. So here it is making rocking motions. So no link is going to make complete revolution. It's highly impossible whenever this Greshoff's law is violated. So S plus L is greater than P plus Q being it is violated. So we will be getting only rocking motion. So அப்போ என்ன difficulty வரும் பாருங்க. Other links are going to make only rocking motion. Then what difficulty you are going to face when Greshoff's law is violated? Any idea?
prime mover
Exactly correct. Prime mover connect பண்றது வந்து difficulty. Why? Prime mover is going to make continuous rotation. The continuous rotate ஆயிட்டே இருக்கும். So at least ஒரு link வந்து continuous rotate ஆனாதான் it is very comfortable to connect the prime mover with one of the links. Okay. In the previous case, we connected the prime mover with the shortest link. So அது வந்து கண்டிப்பா ஒரு complete revolution rotate பண்ணும். So அதை கூட connect பண்ணியிருக்கோம். இப்போ we know that none of the link is going to make complete revolution. So connecting the prime mover with any of the links is highly difficult. So for this we need to make some suitable other arrangements for connecting the prime mover with this link. So it cannot be directly coupled. Prime mover cannot be directly coupled with your links used in this type of class 2 kinematic chain. So that is the one limitations or a disadvantage of the class 2 type. Now tell me, for example, assume this particular case A. So what type of whether it is